Okay, so we need to be able to find the derivative using first principles. This is much trickier than applying our differentiation rules that we'll soon learn. Okay, here in red is the formula for the derivative f dash x using the first principles formula. So this is what we're going to substitute into. So try and keep your notation nice. So it's f dash x is equal to, we're just going to substitute in this formula, the limit as h tends to 0 for, okay, now we're going to substitute. So we have x plus h to the power of 4 minus x to the power of 4 all over h. Now, in this next line, I'm just not going to copy out this limit notation over and over again, and instead I'm going to use Pascal's triangle or binomial theorem if you prefer to expand out my x plus h to the power of 4. So the first term, x, is going to be 4, and then my next coefficient is going to be 4. So its first coefficient is 1, the next coefficient is 4, and that's going to be x cubed h. The next coefficient is 6, so plus 6. So my x terms are decreasing by 1, and my h terms are increasing by 1. The next coefficient is 4 again, so I'm down to x. H goes up to 3, and then finally my coefficient is 1, and it's h to the 4. So that's x plus h will, to the power of 4, and of course I have to go minus x to the 4 for this term here, right? And the whole thing is divided by h. Okay, now I can immediately see I've got a simplification here and here. X to the 4 minus x to the 4 is 0. And then in this next line, what I want to do is I can also see that I have an h in every term. So I'm going to want to factor out the h. So if I bring the h to the front, I have 4x cubed plus 6x squared plus 4x, oh whoops, sorry, okay, let's go back here, 4x squared times 1h, right, plus 4x h squared plus h cubed, all divided by h again, and of course the h's cancel, and this gives me, and now I'm actually going to write it again, the limit as h tends to 0. What I have is 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Now we're going to apply the limit. We're going to say let h tend to 0, so this term here is going to become 0, this term here is going to become 0, this term here is going to become 0. So what we finally end up with is f dash x, or the derivative, is equal to just our only remaining term, 4x to the power of 3.